ARF bundle. This is the parts you get for Sunny Sky Motors, 2300 kV, proven great motors for minis. 412 quadra-stereo 12 amp ESCs with Simon K flash for high kV motors. Get the frame plates, and then bundle of hardware, power distribution board, the motor mounts, the landing tailons, Mobius mount, nylon standoffs, and then these are the balls from Mobius. So then the end result is going to be one of these mini Mambas, and I got two here that are already built. I wanted to show the difference between routing the wires in the arm tubes and not in the arm tubes. This one here is just routed externally and then wrapped in some wire conduit, and it's a mesh conduit. It looks pretty clean even that way, and it saves you a lot of time. And then put a zip tie there to secure it. And then if you route the motor wires and then through the arm tubes, you've got to add motor extension wires, and it's a lot more soldering and a little more fiddling around to get wires in there. Following the 10-step Mini Mamba assembly sequence that I have on the website, gives you an order for probably the most optimal way of putting everything together. Just again laying out so you can see all the parts that come in the ARF bundle kit with a orange receiver option and a Nazi Acro Maze 32. And I'm going to build with red motor mount clamps. So one change I'm going to make is the flight control protective cover. It's engraved with quadra-stereo. I'm going to put it and swap it for a red one. Step one is to build two arm tube sub-assemblies. So we're going to attach the motor mounts and landing tailons to the arm tubes and use the aluminum arm clamps on each motor mount. Move everything else out of the way. Use this set of stuff right here. Keep them loose, and then you'll just be able to slide them right on. Make up 4 of those. The next step, now that we have all 8 of the motor mount clamps on with the loose fits, it's time to put them on the arm tubes. And because the tailons fit over and in between, fit over the tube and in between the clamps, it's easiest just to insert the landing tailon right here. These square holes go in the square pegs go in the round hole. Is that correct? And then it just simply slides straight in through the tube clamps, through the motor mount, through the tailon, and then before we tighten it, we're going to line everything up. We want to line it up close to the edge, not all the way at the edge, maybe a millimeter off the end of the tube. And then you want to face this open slot in the center for motor wires if you choose. It's optional, but if you choose to route your motor wires down through the arm tubes, it's nice and clean. They'll come out here. So you want them facing into the sandwich of the frame plate. So you don't want this pointing up or pointing down, just pointing to the side. And then you want to level them in the same plane, so just simply get them on a flat table surface, or it's even better if you have some really flat, stable like plywood, then suspend it across the plywood nice and flat, and make sure they're flat and in the same plane. and then you can go ahead and tighten them up. Okay, and there we have it. There's one completed arm subassembly. Move on and repeat it for the next arm. The same process. Okay, there you have it. The next step, 2, add the motors to the arm subassemblies. So here's where we have the choice to route the motor wires through the arm tubes for clean look, or just route them outside to save time. Like I just said earlier, I'm going to route them outside, but I could go ahead and add the motors on here now anyway, but I'm going to wait. If you were to add the route the wires in the arm tubes, yeah, you would go ahead and do your motor wire extensions on here. You're going to need about 70-80 millimeters of wire to come down and through and have room to solder to your ESCs, or to add bullet connectors and connect them and be able to swap and make sure you got the right rotation, all that business. We're going to skip that then and move to step number 3, build the power subassembly. What this is soldering the ESCs and the battery leads to the power distribution board. And see, this nifty little power distribution board has 2 built-in BECs. So, but you could, if you had, like I said, opto ESCs, you could have one of these is 12 volts for your FPV camera and video transmitter, and the other one could be 5 volts for your RC gear. And you could use opto ESC. They both have their own adjustment screws for voltage, so you turn that, and you need a voltmeter to make sure you got the right voltage. Most of the time on my builds, though, I mean, I'm using ESCs that have built-in BECs, so I just use that to power the flight controller and RC gear. Now, the voltage regulators on here, they are not step up, so if you've got a 3S battery that's running low down at like 10 volts, and there's a little bit of drop off in efficiency too, you're probably going to get like 9.7 volts. Get the ESCs out. The way we're going to set this in the quad is the bottom frame plate. It'll come in about so, like this. And these will be upside down because the positive's on that side. And then on the big tabs, we'll have the battery lead. Take the battery lead. The battery lead will go here. And the battery lead's going to exit out this large hole here. So we're going to lay it down this direction. And then lastly, I will add a JST connector to tap into one of these back outputs for an FPV for 12 volts.
actually getting us to the next step, which is we're going to add it to the bottom frame plate. This is the front where the CCD camera is, and I have quadrist area down, and this is the inside. Now, these 4 spots are where the nylon standoffs go for the frame plate, so it's best to put those in first so you know where to avoid. So there we have nice completed power distribution board, covered up with a little electrical tape where it's going to potentially contact the carbon fiber frame. Now next I'm going to adjust this output screw to get 12 volts out of this tap. I'm going to leave B output unused. Okay, we got 11.4 volts. Okay, so here's a 4-cell battery to make sure that I didn't go to like 14 amps or something. Yeah, you want to make that adjustment with a 4-cell battery, because as I said, it's not a step up. So if you have a 3-cell that's a low charge, you could potentially be overturning that up. So when you put a 4-cell battery on there and you're not at 12, you fry your gear. Okay, so there we have a completed and power adjusted power distribution output. So the next step is to attach this to the frame plate. And this is a pretty kind of a, rigid assembly. Once you've held down the ESCs to the frame plate, this power distribution board isn't going to go anywhere, so you really don't need screws. Also, okay, so the trick to this, to get everything lined up where you want it, the arms are going to clamp in here. So that's where the wires would be coming out if you're going to route wires down the arm tube. So what you're going to want to do is make sure these guys are kind of scrunched back in a little bit. So we've done number 4, added the power assembly to the lower frame plate. If you're going to add FPV gear, this is a good time to finish that harness onto here. So if you put like a CCD pilot cam here, and run the wires from it, and a video transmitter here, get the wiring harness ready for it, get it all plugged in. So the next step is to add the top frame plate. Now, while it's still easy to access the underside of the top frame plate, now is a good time to put the FC, the flight controller standoffs on. If you have a Naze 32, it's going to use the inside of this slot. If you have a KK, it's the outer part. Outer part 45mm, inner part I think 30mm. So using the same slot, the protective cover is a 45mm. And if you're using a 45mm flight controller, then you can just stack them up on the same standoff. So there you go. The Naze will go inside here, and then this protective cover is going to go right on top of there. And there's ample room with these nylon standoffs. So now we're ready to attach the top frame plate. So this is just simply routing ESC wires through the center hole and screwing in nylon screws. Okay, so there you have the top frame plate attached. Got the ESCs in there, nice and clean, hidden away. Motor wires, easy to access once you get those arms on there. So, step 6 is joining the arm subassemblies to the main frame. And at this point, if you were to have been routing your wires down, the motor wires down the arm tubes, then this would be a good time to temporarily attach them, like just with clips or something, and check the motor rotation. So you would have, these are provided, by the way, these aren't the motor wire extensions if you needed, if you're going to do that. So the motor wires would be coming down there, coming through here, coming out the center tube, and be here, and clip them together. You'd have to have your flight controller, you know, or at minimum, get them all soldered up, and then before you attach your arms. But for this build, I am not routing the wires through the arm tube, so we don't even actually need to put the motors on until the very end. So what we're doing now is get the block arm clamps for the body. We go here and here and here and here. We do is the clamps line up tangent to the end of these slots. So the clamps are going to go about right here, so, and that's here. Slide it in. Line up the holes. Get a bolt through there. Once you get the first bolt in, then it's a lot easier to get the rest lined up. Okay, so at this point, you just want to think the arms snugged up, but you want to still be able to rotate them. Because now we're going to center them onto the frame. It should be 22 millimeters between the edge of the motor mount and the frame. Alright, now at this point, if you're going to fly a standard just flat plane configuration, because you know the mini Mamba, you can rotate them forward. To do a flat plane, put it on a piece of wood like this to line it up, or flat, actually these are getting in the ways. You would flatten out the motor mounts on a nice flat table surface. The alternative is to do the arm rotation. Then you're going to need to use something like, what I find most helpful is like a carpenter's miter for making plumb cuts, and miter for carpenter. You just set this at, actually had it at 9.5 last time. Set it at 10 degrees, and then you would just come under the motor mount like this, go 10 degrees. Actually, that's backwards. This is the front. So turn it around.
That's good. So that'd be 10 degrees, and if you're going to fly that way, then I can go ahead and tighten this up. Okay, so there you see the completed frame at 10-degree rotation forward. The main purpose of this video was to show you the frame construction. So there's only a couple more things left with the frame. 3 things actually. There's the CCD mount, the Mobius mount, and the video transmitter cover I wanted to show you real quick. So the Mobius mount goes right here on the front of the frame. These are 9mm holes for these damping balls. So all you do is simply insert the damping balls in the holes here, down the bottom, down on the top. Great, totally vibration-free video I've gotten with the Mobius with that. The CCD camera mount just simply goes in these 3 interlocking spots here. Because when you're in forward flight in FPV, you want this tipped back as far as you can get it. Hopefully you can see that. So I would set it like that, let the epoxy dry. I have crashed, by the way, this does look vulnerable, but I have yet to do any damage to that camera. Most, like, I've been breaking props and stuff like that. Have yet to break that. And then lastly is the video transmitter bay in the back. Now there is an interlocking piece here. It's like just a little cover, really just for aesthetic purposes. And if you have a small video transmitter such as this one here, 200 milliwatt video transmitter, then you can actually use this little cover. And I highly recommend, because carbon fiber is electrically conductive, I put hot glue around the SMA cover just to be, I don't know if you would get a messed up signal, but just to be safe, didn't want any kind of grounding or funky stuff going on there. But you can just pull the plates apart, and it interlocks like that. It doesn't need any glue or anything. It's really, really tight. So that's how that goes in. Now on my other quad, I have a bigger transmitter. It's a 600 milliwatt. And the 600 milliwatt is just a little bit too long to fit in there. So I don't have the cover on it at all. It just hangs out the back a little. And I have some double stick tape on top and some foam on bottom to secure it in there, and it's not moving anywhere. There's multiple slots down here for battery strap. So I tend to try to keep it in the middle for balance. And since there's no other gear down here, it works great. I put 1500 milliamp 3S is what I usually fly, and it fits great right here. And then of course this is a good one to look at here to see the Mobius camera on it. You'll see I put foam under here. That angles the camera up even more for forward flight, and make sure, like, this is a wide angle Mobius. They tend to pick up a little of the CCD camera if you put it down flat. So I recommend jacking the front up just a little like that. And then here you can see I have the Naze 32 with both the voltage monitor as well as the buzzer attached, and just a simple Spectrum Orange receiver. And this is an IB Crazy air screw. It's great. I use the Mad Mushroom for the receiver. And that's all I got for you today, guys. If you have any comments or like this video, please subscribe to my channel and thumbs up below.